geometry classes. This is circles, lesson 4. Today we're going to talk about congruent chords and arcs. So two chords are congruent if and only if. Let's go over what a chord is. So my chords are what I'm highlighting in green right here, A, B, and C, D. So they're congruent if their corresponding arcs are congruent. And I'll highlight those also. They're congruent if their corresponding arcs are congruent. All right, so that's one way. Which are the arcs? I'll do the arcs in yellow. Okay, so there we go. So basically, if AB, the chord, is congruent to CD, if and only if arc AB is congruent to arc CD. So if the chords are congruent, the arcs are congruent. If the arcs are congruent, then the chords are congruent. Okay? And another way they could be congruent if they are equidistant, that means the same distance, if they are equidistant from the center. So AB, again, is equal to or congruent to CD, if and only if they're the same distance from the center. So if I have EF is congruent to EG. And let me do that in a different color. I'll do that in blue. So basically, if the distance they are from the center is congruent, then those chords also have to be congruent. Okay? And that should make a little bit of sense, because if the arcs are congruent, then the chords have to be the same distance away from the outside of the circle. And if FE and EG are congruent, then again the chords are the same distance away from the center. They have to be the same length, because the further you get from the center, then the smaller your chords are going to get. If the diameter or radius is perpendicular, so here's another fact. So if the diameter or radius is perpendicular to a chord, then it bisects the chord, and it also bisects its arc. So basically, if I'm telling you that EH is perpendicular to AB, okay, see how that's drawn right here already, the perpendicular symbol's on there, then that means that AF is equal to FB. So I cut the chord in half. And I also cut the arc in half. So arc AH is equal to arc HB. So if a radius or diameter is perpendicular to a chord, it bisects the chord, it cuts the chord in half, and it also bisects the arc, cuts the arc in half. All right, so let's look at what we have down here. So in number 1, I'm telling you that these chords are congruent. See how they're marked congruent right here. If they're congruent, then that means that these arcs have to be congruent. So I need to set up an equation and solve for x. I'm just going to take those two arcs and I'm going to set them equal to each other and solve. So 7x plus 24 equals 115. I'm going to subtract 24 from both sides. 115 minus 24 is 91. And then when I divide by 7, I get x equals 13. Now in the next one, I have the reverse. I'm telling you that the arcs are congruent. See how they're marked congruent? Therefore, those chords also have to be congruent. So same thing, I'm just going to set them equal to each other. 18x minus 2 equals 52. I'm going to solve for x by adding 2 to both sides and divide by 18, x equals 3. All right, number 3, getting a little bit trickier. The chords are congruent, okay? That makes the arcs congruent. So I know that this arc ZY is going to be 6x minus 20. That makes arc XY also 6x minus 20. So the arcs have to be congruent. ZY is going to be congruent to arc XY. And if you think about it, all 3 arcs form a complete circle. All right, so you're going to take all 3 arcs, the 6x minus 20, the 6x minus 20, and also the 76, and I'm going to set all three of them equal to 360. Okay, so that means I have 12x. Negative 20 and negative 20 is negative 40, but then I'm adding 76. So 12x plus 36 equals 360. Subtract 36, and I have 12x equals 324. Divide by 12, x equals 27. Okay, so a couple different problems. Now in this next one, DE, which is this chord right here, and FG, which is this chord right here, they tell me what they are equal, and then it says find DE. Well, what's true about them? Look, what's true is that they are the same distance from the center of the circle. If they are the same distance from the center of the circle, then DE is going to be equal to FG. So all I'm going to do is take DE and set it equal to FG and solve. Okay, I'm going to subtract the 3x. That gives me 8x. Whoops, I think I messed up. I did mess up, so sorry. This was a 32, not a 3. Okay, I had the wrong number. 32x minus 27. I was wondering why the number on my paper was a little bit different. There we go, all fixed. So I'm going to subtract 11x. Subtract 11x. That gives me 21x. I'm going to add 27. That gives me 42. And dividing by 21, x equals 2. Now be careful on this one though, because they're asking me to find DE. So all I have to do is just to go back and substitute. So DE equals 11 times 2 plus 15. So DE equals 37. All right. And then we have a little bit more practice on this side. So if MP is 5x minus 34 and PN is 2x minus 4, all right, so MP, it's going to be hard to write that in there, so I'm just going to highlight them so you can see it. And PN is 2x minus 4. Find MP. So basically I need an equation. Well, here's the deal. Look at your picture. These arcs are congruent. So KJ is congruent, arc KJ is congruent to arc KL. If the arcs are congruent, then that means chord KL is congruent to chord KJ. So if the arcs are congruent, then the chords are congruent. And if the chords are congruent, then that means they have to be the same distance from the center of the circle. So then that means MP is congruent to PN. So all I'm going to do is set those equal to each other and solve. So 5x minus 34 equals 2x minus 4. So you got to think about what you know and how you can write your equation. What's true? So I'm just solving for x. I'm going to add 34. And I get x equals 10. Now this one also I want to know MP. So all I'm doing is substituting in 5 times 10 minus 34. All right. QM is 6x minus 11. So this part right here is 6x minus 11. It's going to be hard to write that on my picture. MR is right here, and that's 2x plus 9. Find MN. Well, here's the deal. If you notice, if you look at the picture, these chords, which I'm going to highlight in yellow, are congruent to each other. Why? Because they're the same distance from the center of the circle. Look at your picture. These little pieces, all right, QP is congruent to PR. If that's true, then the chords are congruent. So LM is congruent to NM. And those QP and PR are perpendicular. If they're perpendicular, that means they're cutting the chords in half. So if the chords are congruent and they're cut in half, then that means half of one chord is equal to half of the other chord. So there I go. That's my mathematical facts. And since that's all true, I'm going to set those two little pieces that I have in red equal to each other. So you can see a lot of these were just about, whoops, I'm subtracting 2x. A lot of them are just about setting things equal to each other. There has to be a reason though, there has to be a justification. And I get x equals 5. All right. Once I know that x equals 5, then I can find whatever I want. So actually, yeah, we're not going to do any of this. We're just going to find mn. I think that's there by mistake. That was from a different problem. Sorry about that. So I'm basically going to find mr, which is 2 times 5 plus 9 is 19. But if I want to know mn is the whole line. Since half of it's 19, then I have to do 2 times 19, which is 38. Okay. And in this next one, let's see what happens. I want to find VW. So VW is this line that I'm going to highlight here in green. All right. Let's first find, is that VW? That's the right one. This is a right triangle. I don't know if you guys are noticing that, right? That this is a right triangle right here. So I can call this little thing x, and I have 5 squared plus x squared equals 13 squared. This is actually one of the Pythagorean triples, so I already know the answer, but I'm doing it out anyway. Remember, your hypotenuse has to be your smallest side. So I have 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. I subtract 25 and I get 144, so x equals 12. But I wanted to find VW, so I have to do 2 times 12, which is 24. And then the next one wanted me to find arc YW. So let's do that in a different color. How about I'll do that in pink? I want to do this arc right there. Well, that arc is equal to angle arc YW. All right. Oops, I didn't mean the angle sign. Arc YW. Now I want the angle. Is congruent to angle YXW. It's congruent to this angle that I'm going to do in, I don't know, red. So this angle, right, is a central angle. It equals whatever that is. I can use trig to find that angle, right? All I really have is I have this triangle. These sides are 5, this side is 12, this side is 13, and I'm trying to find that angle right there. All right, so I can use trig, and I could say sine of x equals 12 over 13. And then x equals, I need the inverse button. All right, so even though, whoops, I haven't done trig in a while, here's a trig problem. All right, so I'm trying to find the angle right here that I just called angle x. I redrew my right triangle out here. I'll highlight it the same color just so you can see that all I did was redraw that triangle. This was opposite and this was hypotenuse. When you have all 3 sides, you get to decide what you're going to use. I just decided to use sine. And I get 67.38, which is 68 degrees. Okay, last one. RS is 18. All right, RS is this line right here. But notice that ZX is a radius, is perpendicular. That means I'm cutting the line in half. Right? So that makes this part 9 and this part 9. And that's actually one of my questions. Well, the first question wants to know TV. TV is this part right here. Now, TV will also be 9 because these chords are the same distance from the center of the circle, so those chords are congruent to each other. So if they're the same distance, if they're equidistant from the center of the circle, they're congruent. The chords are congruent that I have drawn in red. And if those lines are perpendicular, then it's cutting those chords in half. So TV is 9. TU is going to be 18. TU is the whole thing. WS, I just have to find my W. My WS is up here. And WS, I'll do it in blue. WS is right there, is half of 18, is also 9. Arc YU, let's find a different color. So arc YU is right there. And that arc is going to be, I think that I'm missing a piece of information. Oh, so this, I'm missing this information right here. Arc TY is 42. So remember, if that's perpendicular, it bisects the chord and it also bisects the arc. So these are congruent. So that's also 42. So this is just going over some rules with us. There's no equations that we're doing on this. And then the last question wants to know what arc RS is. So arc RS is this right here. It's going to be equal to the other one, so it also will be 42 and 42. If the chords are congruent, then the arcs are congruent. So that will be 84. Okay, so we're just going to practice all those rules tomorrow.